Hello everyone, welcome back to this channel. Previously we have made subsequent tutorials regarding to the different mode flow packages. And in this tutorial we will see how to model the well package and perform the overall flow simulation under the steady state flow simulation. As usual, we can open our model, go to File and then Open Model. Here is my project under desktop directory and then open. Okay. Go to Models menu and then Flow Package. Here is Well Package. And then here is our study area. So this package simulates wells that withdraw water from or add water to the aquifer at a constant rate. That means the well may be an injection well or a pumping well, defined by using cell by cell or polygon input method. This is a cell by cell or this is a polygon input method. In doing so, all the injection and pumping wells are independent of the cell area and the hydraulic head in the cell. Okay. For this demonstration, I do have one pumping well with a value of -30 because pumping wells are represented by negative values, and I do have two injection wells with a value of 20 meter cube per second and 40 meter cube per second, including 6 observation wells in my study area. So I have to just add these wells to this model. Around this I have to add one pumping well. Just click and then right click, input -30 and then OK. Okay. For demonstration I will just zoom out this. Okay, then I do have two injection wells around this. (20 meter cube per second). Okay, and here's the one. Here I do have an injection well with a value of 40 meter cube per second, and then OK. Okay, here I can just save my worked wells, and then we can just save the change. Yes, the remaining one is we have to just add our observation wells. Go to models, flow simulation, and then head observations. Okay, under this dialog box we have to input the name with a character I have to activate this, and then I can say observation 1 is a value of x 29 79, 37, and y with a value of 12, 82, 40, 840, 840. Okay, and then we have to just make our proportion 1 time 1 and the head observation value, that is a z value, 1865. Okay, now to just input his value, observation wheel 2 is a value of x, 28, 95, 87, and then 25, proportion 1 time 1, and head observation, that is the z value, 1562, white 1. Okay, I just missed the white for the observation wheel 1. Just have to add or type the white one. It is our observation 2, and I do have observation wheel 3. Observation wheel 4. Observation 5. Okay, here is our observation wheel 1, 2, 3, 4, 7, 8. Okay, then we can just okay. After this, we can go to models and then solvers. MODFLOW solvers, in most cases, the choice of the solver depends on the problem itself, and then it is difficult to determine which solution method is better than the other. For example, this D45 is a direct solution method, whereas the PCG2 preconditional conjugate graduates 2 and SIP strongly implicit procedure. So the solver may have different methods to process the simulation in MODFLOW. And then it's difficult to determine which solver is used, and it depends on the problem itself. Okay, for this simulation, I do want check the PCG2, and then after selecting this, we have to adjust our output menu. If you click this is MODFLOW output control. This menu is control the frequency and amount of simulation results of the MODFLOW that will be printed or saved. For example, the first parameter is hydraulic head, including drawdown, cell by cell flow terms, volumetric, water budget, etc. And then you can check and uncheck as per your interest to process this package, and then okay. Then after this, go to models and flow package and then run. When you run the MODFLOW, it has a generate option, description, and designation file where the file is saved. So I will just check all the boxes to be processed or run for the simulation, and then I can say okay. Okay, here is it. The simulation is started. Okay. After processing, it says press any key to continue. That is, the flow simulation is finished. Okay. After this, we can see the result values under tools menu and then to the visualization. Okay, you can change the parameter, replicate, drawdown, compaction, constant recharge upon your interest. Let's see the hydraulic. Okay. Okay. Here is our hydraulic result. If you wish to make changes on the hydraulic contour values, go to options and then environment and then contour line. If you wish, you can fill the contours and then you can adjust the values, minimum value and maximum. I am interested to make the contour interval as 50 meter and then OK. Label format, OK, fix it and then OK. Okay, this is a contour interval. If you guys want to show the contour interval in different ways, you can proceed just like this. Okay. Also, you can see the water budget, and then you can also see the run listing file, head scatter diagram. For example, we can see the head scatter diagram. We do have the observation name, observation 1, 2, 3, 4, 5, 6. We have just input the head observation values and calculated values are here, and then we can see in chart form. Okay. 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 That's good result. The other one is the under tools menu, water budget. Here we do have only one stress period. Just we have one layer with one stress period with one time step. So we can create this water budget, or either we can define sub-regions. Okay, for this region and for this region, you can make different methods. See, if you wish, you can just make one and then sub-region number 1. Okay, and then you can transpose this value and then OK. Okay, I do have one region, and then also I want to model one region as well, sub-region number 2, and then I can transpose this and then OK. See, I do have this region and one region also. Sub-region number 3 and then transpose. Okay. Okay. Here we do have sub-region 1, sub-region 2, and sub-region 3. Okay. Save changes to the sub-region. Yes, and then we can define and calculate the water base. Then okay, here is it. And then we can proceed by entering any key, and then automatically our water budget will be displayed. Okay, from region 1 in layer 1, I do have storage, constant head, horizontal, exchange upper, exchange lower, river leakage, head, stream leakage, intermediate storage. This type of kind of parameters are calculated, and then you can express or point out the input output, the balance. What will be if for example, under wells, the input is 0, the output is also 0. What will be, for example, the well, the input value of the well will be higher value, and the output will be just, I mean, if we would have well value, the input value of the well much greater than that of the output value of the well. So the well did not feed the river, rather it gains from the river. In such analysis you can make from your water budget. Okay, I hope our consecutive tutorials will help you. In the coming days, we will show you how a two-layer transit flow model. Thanks for watching. See you next time.